Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to learn the new topic, which is non-parametric statistics. So what are the non-parametric statistics? Non-parametric are the methods of statistical analysis that do not require distribution to meet the required assumptions to be analyzed. This is the topic outline for this chapter. The first one is the introduction. Second one is the goodness of fit test. The third one is independent test. And the last one is homogeneity test. So in this video, we are going to focus on the introduction and the goodness of fit test. Previously, we have seen data where it is either assumed or known to follow a certain distribution. For example, Poisson distribution, binomial distribution, and normal distribution. So the goodness of fit test is used to check such assumption. And independence and homogeneity test are two methods to deal data presented in contingency table. So now let's see what is the goodness of fit test. A chi-square goodness of fit test is used to see whether a frequency distribution fits a specific pattern. Here we have a situation. Let's say you are a market analyst, and you want to see whether your customer have any preference among the 5 flavors of a new fruit soda. And we have a sample of 100 people. And this is the flavor for the new fruit soda. Here we have cherry, strawberry, orange, lime, and grape. And this value is the people that choose for cherry. 28 choose strawberry, 16 orange, 14 is for lime, and grape is for 10 people. Alright, so all these values, we call it as the observed frequency, where observed frequency is the frequency that we obtain from a sample. Okay, so observed frequency, we denote it as OI. Okay, I is represent the number of category that we have here. Okay, let's say O1 will be the value of 32, where it is obtained from the first category, which is cherry. O2 would be the value of frequencies from the second category, which is from strawberry. So O2 would be equals to 28. And O3 is 16, O4 is 14, and the last one is O5 is equals to 10. So that is the observed frequency. Okay, the next thing that you need to know in the goodness of fit test is the frequencies obtained by calculation, okay, as if there were no preference, okay, where we call it as expected frequencies. So here is the formula for the expected frequencies given as EI. Here I is represented the category. So since the last slide, we have 5 categories. So it will be E1, E2, E3 up until E5, where the expected frequencies is equals to N times with PI, given that N is the total number of observation. So for our case, the total number of observation is equals to 100 because we have a sample of 100 people. And PI is the probability for that category. So the probability for our case is the probability of getting cherry, lime, grape, and so on. Okay. So looking at the new fruit flavors example, okay, if there were no preference, okay, you would expect that each flavor to be selected with equal frequency. For in this case, okay, the expected frequency is given as N, which is 100, okay, times with the probability of choosing cherry, where we have 5 flavors, Okay, so the probability of choosing cherry among 5 flavors would be 1 over 5. So for the first one, the expected frequency for cherry should be equals to 20. Same goes for the second flavor, which is equals to the total number of observation times with the probability of choosing the second flavor out of 5 flavors would be 1 over 5, should be equals to 20. Same goes for the third, fourth and fifth flavors. So here we have approximately 20 people would select each flavor. So remember that the expected frequency that we would expect that each flavor to be selected with equal frequency. So now I add the second column, the second row, given this is the value for the expected frequency, which is 20 for each column. So the observed frequencies will almost always differ from the expected frequencies due to the sampling error, okay, which means that the values differ from sample to sample. But the question is, are these differences significant? Okay, a preference exists, or are they due to chance? So the chi-square goodness of fit test will enable us to determine the answer. So before we compute the test value, we must state the hypothesis. Okay, so the null hypothesis should be a statement where it indicates that there is no difference or no change. For example, for our case, is the null hypothesis would be the consumers show no preference for flavors of the fruit soda, and the alternative would be the consumers show a preference. Okay, next we need to measure the discrepancy between the observed value and the expected values given as E. So we use the test statistic for the chi-square goodness of fit test. Okay, so the formula for the chi-square goodness of fit test is given as chi-square equals to the summation of the observed value, the observed frequency for that category minus with the expected frequency of that category. Then we square this over the expected frequency and we find the summation of this, and that is our chi-square test. Here I have rewrite back the observed frequency, and this is the expected frequency obtained from the formula, which is n times with the probability for that category. And here is the chi-square goodness of fit test, where the formula is obtained, where the value here is obtained from this formula. So to get 7.2 is equals to 32 minus 20, and we square the value, divide by 20, and we have this 7.2. Same goes for the rest of the category. Alright, so to know the value of the chi-square test is just that we find the summation of this column. So chi-square test is equals to 18. This chi-square goodness of fit test is a one-tailed test, where at the significance level of alpha, we will reject H0 if the statistics is greater than critical value. So the critical value that we need to find is the chi-square alpha, k minus p minus 1. Given k is the number of categories and p is the number of parameters estimated from the sample data used to generate the hypothesized distribution. So in our cases, let's say we have alpha equals to 0.05. Okay, and to find the critical value, we will have the k, which is given as we have 5 flavors, okay, and you can see that the parameters estimated from the sample data, we don't estimate any parameters from the sample data, so the parameters would be equals to 0. So we just have to find 5 minus 0 minus 1, which is equals to 9.488. Okay, and from the calculation that we got, which is chi-square is equals to 18, so we can see that this chi-square is greater than critical value 9.488, so we can conclude that we reject H note. Okay, there is enough evidence to reject the consumers show no preference for the flavors. Okay, to get some idea of why this test is called the goodness of fit test, examine graph of the observed value and expected values from previous example. So here the blue line shows the observed value. Okay, given the value for cherry is 32, strawberry is 20 something, and so on. Okay, and here we have the expected values, which is all equals to 20. So from the graph, you can see whether the observed value and the expected values are close together or far apart. So from our cases, okay, the observed value and the expected value are far apart. So this is not a good fit. Okay, so as a result, we reject the null hypothesis. Okay, now after this, we will go through the example of the goodness of fit test.